Good afternoon, everyone. I'm Kartik. I'm a product manager at Microsoft. I'm part of the Azure security team, and we work on securing confidential computing and enabling transparency. And today I'm excited to talk to you about our upcoming product, Cloud Transparency Service. Cloud Transparency Service is a confidential grade Azure service designed to provide a comprehensive tamper-proof history of all software releases that are authorized by configurable registration policies. And our plan is to leverage this to provide trust in Microsoft services through verifiable transparency and auditability. So before we jump into the product itself, let's quickly align on some definitions of transparency. The way we look at it is transparency is authenticity plus non-equivocation. Simply put, authenticity is that all statements are verifiably attributable to the parties that made them, and they've not been tampered with since. And non-equivocation is nothing but a single history of statements, a single source of truth. Basically, everybody in this particular ecosystem is on the same page. But transparency standalone doesn't really achieve much. Enforcement is what critically matters. So transparency cannot be an optional feature that is occasionally implemented, occasionally observed. It has to be in the critical path, it has to be enforced, and you need to continuously or routinely monitor it to derive value from it, which is accountability. And so today we are talking, or I will be talking about how we implement transparency with the Cloud Transparency Service that we've built. And to do so, let's quickly jump into a workflow of our plans of how we plan to use CTS to bring trust and auditability to the root of confidential computing in Azure services such as Microsoft Azure Attestation and Azure Managed Hardware Security Module, or MHSM. So let's go through a typical workflow. If I'm a developer or an engineer in one of these confidential services, I'm looking to update the code. I send the binaries, the code, build artifacts, etc., to the build pipeline. The build pipeline then typically has an action to go ahead and get this signed by the code signing service. This happens in production today. But going forward, the code signing service is fully integrated with our Cloud Transparency Service. So in addition to signing these artifacts, it's looking to register these signing details on an immutable ledger. So it connects with CTS, but CTS doesn't just allow anything to be updated on it. It performs a bunch of policy enforcements. So for example, the first one would be identity verification. It will ensure that only a valid identity of a issuer, or in this case, a service owner, is allowed to update the ledger. But even if it meets the identity requirements, it will perform a check for the content being updated. Things like, today it's a little bit more simplistic maybe in terms of the payload, the subject, the security version number, the code measurements within the TE of MA and MHSM that have been captured, etc. But in the full future state, we fully expect the customers to be able to configure this, or the service owners to configure this, so they can decide for themselves what are the registration policies they want to enforce. And then the CTS ledger is designed to be append-only immutable ledger built on Confidential Consortium Framework, which means once you update it, you cannot modify it, you cannot tamper it, and you get a cryptographic Merkle proof or a CTS receipt that the right transaction was saved successfully. CTS goes ahead and returns the receipt. The code signing service puts together what we call a transparent statement. That's the signature plus the CTS receipt, gives it back to the service owners, and then they take all of this and try to deploy a new version of the confidential service to production. Now, this is where enforcement comes into play. This gives us an opportunity to gate deployments based on the presence of a CTS receipt. Simply put, if a receipt exists, if it meets all the registration policies, you go ahead and deploy it. If it does not, you can block it. What does this mean to our customers? Customers of MAA and MHSM connecting to these confidential services today basically know that they're speaking to an official build of the service. They know it's met the bar, it's cleared the registration policies, a valid identity updated it, and so that gives them immense value. And then this entire unequivocal official build history is auditable by the customer, an auditor on their behalf at any given point of time. Right? So now that we've covered a little bit about what the Cloud Transparency Service looks like in practice, let's talk about why you would want to do that. What's the need for transparency? What are we hoping to gain out of it? So first and foremost, it deters malicious behavior, right? It acts as a strong deterrent for anybody looking to orchestrate certain supply chain attacks because it leaves a trace. It also gives you an opportunity to prevent deployments that are not authorized or do not meet the established quality or policy that you have set. Next, it enables auditability. This can be a human auditor or an artificial auditor in the future. They can periodically analyze a sequence of events that happen. What does that help you do? It helps you potentially detect anomalies, right? Essentially, Cloud Transparency Service is capturing a bunch of changes and actions in the build environment. If you're a security team that is routinely monitoring this build history and you notice any unauthorized access, any malicious software that was introduced that you didn't intend for it to be there, this gives you an opportunity to act on it. Maybe it's a mechanism for you to detect this early on. Maybe this is a mechanism for you to see an ongoing attack and mitigate it, or at the bare minimum, limit the damage. Now, why are we doing all of this? It's all about building trust with our customers, right? So this enables CTS, Cloud Transparency Service, enables customers of confidential computing to execute on a trust but verify model, right? And it does so with minimal effort and minimal cost. And all of these artifacts that are captured on the ledger, etc., are ready for the customer to consume. They have this evidence of compliance which they can use to show that they comply with certain regulatory requirements, industry standards, security policies, right? And so all of this put together, Cloud Transparency Service is looking to build trust in other systems that are a part of Microsoft Azure's confidential computing. So if you need to trust that, you need to trust CTS itself. So I'll talk to you a little bit about why you would want to trust CTS. So first and foremost, CTS as a service, Cloud Transparency Service, is confidential and attested. Confidential here means it runs in confidential containers in Azure Container Instances. These are basically Linux containers that run inside hardware-backed TEEs that are built on top of AMD SEV-SMP platform. And then CTS has a self-attestation model. The Confidential Consortium Framework it's built on supports this. There's a governance model that supports this as well. Then all the code for Cloud Transparency Service is open source, so you as a customer or an auditor or someone in the industry can go ahead and perform detailed source code reviews. And not only that, the CTS builds are reproducible as well. This is a pretty big one. So we show you the code and then give you the mechanism to prove that the code you just reviewed is what's actually running in production, right? So you don't have to just trust us and believe what we are saying. Also, we've engaged with an industry standard security auditor, a third-party auditor who's performing a detailed security review of CTS. So they are doing architecture review, threat model review, source code review, and dynamic penetration testing. And lastly, just like MAA, MHSM, and other confidential services have their builds recorded on CTS, CTS itself upgrades through that mechanism. So every single time a new upgrade to Cloud Transparency Service is gated on the presence of a CTS receipt captured on the ledger. And so with all of this, what you get is transparency artifacts that are publicly available, auditable by anyone, including security researchers, right? So if you really look at it, you have a confidential service, you can review its codes, you can then reproduce the build, and then you can match what you reproduce with the upgraded version or the code measurements that were captured on the CTS ledger or were in the payload of the CTS receipt. So all in all, you can verify all of this yourself. You don't have to trust the operators of the Cloud Transparency Service. With that, I'm happy to announce that the Azure security team is announcing today an upcoming preview in late September, early October of the CTS integration with Microsoft Azure Attestation and with Azure Managed Hardware Security module. So the customers of the preview will get access to the production releases of these confidential services that are immutably recorded on the ledger. During this preview, here are some features. You can look at them. But essentially, everything I talked about before will be accessible to the customers of the preview. So you get access to the open source code. You can reproduce CTS build. You can see the code measurements of these relying party services, MA and MHSM captured on the CTS ledger. You get access to the tooling to verify these receipts. You get access to the third-party audit report, etc. Right? So if you're interested in participating in this preview, please feel free to reach out to me and the team. And if you want to learn a little bit more about this topic in general, here are some resources. On the left, you have the white paper put together by Azure Research. That's a white paper on code transparency. And on the right are the two IETF drafts. The first one is for the architecture for a transparent digital supply chain. And the second one is the IETF draft on cozy receipts. Cloud Transparency Service is compliant with both of these today. And with that, I would like to end my presentation. If you have any questions for me, feel free to reach out. I'm also going to be available at the poster session later today at 5:30. Thank you so much for your time and attention.